Welcome to Tectonic Nights channel. Let's kick things off with some Rust basics, then we'll dive into BFS problems in Rust. Rust is a compiled systems programming language designed to be fast, reliable, and safe. It provides low-level control similar to C and C++, but with modern features that help prevent common programming errors like memory bugs and data races. Rust's unique ownership system ensures memory safety without needing a garbage collector, making it ideal for performance-critical applications. It's used in areas ranging from embedded systems to web development and game engines. Alright, let's dive in. First up, let's print Hello World in Rust. We do this using the println macro. A quick note that exclamatory means we are using a macro, not a regular function. Let's talk about variables. In Rust, we use the let keyword to bind values to variables. If we want to change a variable later, we use the mute keyword to make it mutable. Now let's look at control flow. Rust has a few cool loop options. First one is the loop keyword itself. This here creates an infinite loop. It will keep running until you break out of it, and you can even return a value when you break. The for loop is great for iterating over a range or a collection. You can set a start point, and if you don't provide an end, it will keep going indefinitely. And like the loop, you cannot break with a value. Similarly, this while loop runs as long as the condition is true. Now let's talk about functions. To define one, use fn keyword followed by the function name and its parameters. In this case, we are using i32 as a type for the parameter and the return value. In Rust, there are no classes. Instead, we use structs to define custom data types. You can then implement methods for these structs. Here's an example. This defines a point struct with two fields, x and y. Here's an example for defining a method offset that adds values to both fields. One of the most important concepts in Rust is ownership. Here are the basic rules. Every value has one owner. There can only be one owner at a time. When the owner goes out of scope, the value is dropped. Here's a quick example with a vector. It's a dynamic array to show how ownership works. When we pass the vector to a function, ownership is transferred to that function. If we try to use the original vector after that, we get an error. If we want to keep ownership, we can pass a reference to the vector instead. A reference can be passed using ampersand. Now let's talk about smart pointers. These are like regular pointers, but with extra features. They allow you to manage memory more safely and efficiently. Box is a pointer that owns the data it points to, and it can only have one owner. Once it goes out of scope, the memory is automatically deallocated. For example, let's define two box arrays, x and y. We will assign a clone of array x to y, then modify an element in y. This demonstrates that only the data in y is changed, while the original array x remains unaffected. Next is RC, that is reference counted. It is a pointer unlike box, allows multiple owners. Each owner has a reference to the same data, and Rust tracks how many references there are. When you use RC, the data is shared, and the memory will be cleaned up once all the references go out of scope. If you want to mutate data behind an RC, you need to use refcell to allow interior mutability. Now let's revisit the example with the box arrays x and y. Here instead of box, let's use RC. After modifying the data in y, we'll see that changes are reflected not only in the cloned array y, but also in the original array x. Finally, let's talk about enums and pattern matching. A common enum in Rust is option, which can either hold sum of value or none. Here's how you can use it with match. You can also simplify things using if-let, which makes it cleaner when you're only interested in one way. Now that we have covered the basics, let's dive into solving some BFS problems on LeetCode. Before we start tackling the problems, let's quickly review the tree node structure and the method for building a tree data structure. In Rust, we can use vec_dec, which is a double-ended queue. If we use a vector to push nodes and pop the front node by removing the element at index 0, a vec needs to rearrange its elements after the first element is removed, which can be inefficient because it requires shifting all the remaining elements. We will use the pushback method to append the root node to the back of the queue. To retrieve a value from the queue, we can use either get method or pop front method. After extracting the node, we use unwrap to get the value from the option enum, and then borrow to borrow a reference to the value from the ref cell which holds the node struct. Let's use if-let to check if the node has a left child. If it does, sum of left variant is assigned a non-null value, and this block of code is executed. Note that when assigning, we need to use clone and pass a reference rather than transferring the ownership of the left child node to sum of left. Similarly, we can check if the node has a right child in the same way. Now let's apply this template to solve a couple of LeetCode problems. First one is Univalued binary tree. We have already solved this problem in Python. Now let's tackle it in Rust. We can fetch the node's value using the borrow method and assign it to a variable called unival. In each iteration of the while loop, we check if the node popped from the queue has a value that matches unival. If it does, we break the loop and return false, indicating that the tree is not univalued. Next problem is finding the average of levels in a binary tree. The only modification needed to the template is the addition of inner loop to process the nodes at the same level. To determine the number of nodes at the current level, we can simply check the length of the queue. Within the inner loop, we dequeue each node, extract its value, and accumulate the level sum. Once the inner loop finishes processing all the nodes at the current level, we can compute the average of the level sum at each level. Thanks for watching this video. If you haven't already, check out my other LeetCode videos in Python and let me know which language you would prefer for future LeetCode challenges. Drop a comment below. Don't forget to like and subscribe. See you in the next one.